Hey guys, let's continue from question 11. So it says the diagram shows some of the changes during the 28-day menstrual cycle. Okay, so this is the menstrual cycle. This is the uterus lining. So the greater the lining here, it means the greater the thickness. In other words, this length here going upwards, it's measuring the thickness of the uterus lining. So here the uterus lining it's 0. Here it's maximum. That's what the diagram is telling us. And then here we have a graph for the for some hormone in blood, for the concentration of that hormone, and it's on the same axis, so the same time axis as the uterus lining. And then we are supposed to compare the two, I guess. So he says, what's the function of the hormone? So you have to compare what is it exactly that the hormone is doing. So yeah, it's saying it causes ovulation, it prevents ovulation, it rebuilds the uterus lining, it maintains the uterus lining. So I'm guessing that this has to do with the uterus lining. As you can see, here we have this part here. It's about the uterus lining, okay? And then how is the uterus lining varying with the hormone? So it can be maintaining or rebuilding. So let's look at it closely. So if it's maintaining, then we would expect this hormone to be in greater concentration here so that it can maintain this level here. But then it's not like that. So where it had higher concentration was when this uterus lining had dipped to 0 thickness according to this, and then it rebuilt that uterus lining, and then when it was done, the hormone levels, they actually dipped. So the answer is the hormone actually rebuilds, not maintains. The hormone rebuilds the uterus lining. Okay, so again, the reason we don't say it maintains is that here when we have the uterus lining, it's done, we actually have very low concentration of the hormone. If it was maintaining, we'd expect the hormone to be at least some value, which is greater than the 0 here. So yeah, that's it. Let's move to the next question. And before we move to the next question, I want you to go in the comment section and then you tell me something. What's this hormone? Is it progesterone? Is it estrogen? Is it any other hormone that you know of? Comment in the just give the name of the hormone, and then you say why you're saying that's the hormone there. So give your reason. So that's it. Let's move to 12. Question 12 says the diagram shows the carbon cycle. Okay, which process A, B, C, or D causes global warming? So we have all these processes here. Which process causes global warming? Okay, so here we have D part. I think this is photosynthesis. Carbon dioxide. It's sinking into something organic. So this is the process of photosynthesis. Okay. So this is photosynthesis. So this doesn't cause global warming. It's actually desirable. That's why we encourage people to plant trees. If you're interested, we encourage you to plant at least 1 tree in a month. That really goes a long way. So do that. And also here, green plants to fuels. This doesn't um, this could be this green plants, they decay, and then after some time they become fuel. Okay, so this, I think it's fossilization, but then you'd have to look it up for yourself and then make sure that it's right. So this one is just nutrition. So the green plants, they've produced um, carbohydrates, and then now animals they're feeding. So herbivores they're feeding on these green plants. So that's what we have. And then this process here now, this is industrial reaction, and then this is where um, global warming comes in. So you can say industrial activity here. So burning of fossil fuels. That's what I'm saying. Industrial activities. So here, this is what causes global warming, at least in part. Okay, only carbon dioxide is not the only greenhouse gas. There are also some other, I think even water vapor, it's also a greenhouse gas. But when you burn fuel, you're actually um, producing carbon dioxide, of which carbon dioxide, it's a greenhouse gas. So let's quickly move to question 13. Question 13, what does it say? It says which statement about the blood circulatory system is true? Okay, so which statement is true about the blood circulatory system? So here it says it is composed of the systemic circulation only. This one, it's not true. This one, it says it's composed of pulmonary circulation only. This one is not true. Okay, so blood circulatory system, it's actually in two parts. There is the pulmonary system, the pulmonary circulation system. So the pulmonary circulation system, it moves blood between the it moves blood between the heart and the lungs. Okay, so the pulmonary system, it moves blood between the heart and the lungs, and then the systemic circulatory system, it moves blood between the heart and the lungs. Okay, between heart and the rest of the body. Sorry, rest of the body. Okay, my handwriting is very bad, but I'm sure you get it. So the blood circulatory system, it's actually comprised. It actually comprises two parts. There's the systemic one. There's the pulmonary one. So the pulmonary one, just like what you said, it's an interaction between the heart and the lungs. Because remember, this is where you actually get the gaseous exchange, and this oxygenated blood, it moves into the heart, so that the heart acts as if it's a pump. It's actually a pump somehow. It pumps that blood so that it goes a long way, covering all the parts of the human body, or the body of that animal organism. So C says the blood moves twice into the heart in one cycle. So this one, let's hang on it a bit. Then the left hand side receives deoxygenated blood. So this is not true. So the left hand side of the of the heart actually receives oxygenated blood. Okay, one way to remember this is that your heart is on the left side, so it's a good thing. So left side is oxygenated blood, which is a good thing again. So it's not exactly apples to apples, but I'm sure you get it. It will help you remember. So this one now, when we come to the C part, it says blood moves twice into the heart in one cycle. This is true. Okay. Actually, we say that blood, it's a double pump, or it's a double ventricle. So um, to the right atrium, when blood is going to the lungs, it goes into the right atrium first, and then it goes into the right ventricle. So it moves twice in that cycle, and then when blood is going towards the body, it moves to the left atrium, and then it moves to the left ventricle. Okay, so this one would be the correct answer here. It's true about the blood circulatory system. Let's quickly move to question 14. Question 14 says, which organism causes malaria? So here, I advise you to actually just know it. This is general knowledge. So it's Plasmodium. Okay, so Plasmodium is the organism that causes malaria. Okay, it's an organism, as in it's a parasite. It's actually they say eukaryotic, so it means it's made up of many cells. So it's not single celled as a bacterium here. So it's actually an organism. It's a parasite, and what this parasite does really is that um, it inserts itself into a host. Okay, so into an insect host. So for our case, it'd be the insect would be a mosquito. Okay. So this one is called a host. Okay. So when it's in a mosquito, and there's a reason why it chooses a mosquito, because a mosquito is what is blood feeding. So a mosquito actually loves blood. So it also makes for good nutrition for this parasite here. Parasite means that it's actually feeding off of another organism. Okay, so it just attaches itself so that it gets this gain, so blood. And then after feeding off of the mosquito for some time in its life cycle, we say that it's obligate parasite. By the way, I want you to go and look up what this means, and you can comment in the comment section, but I want you to know for yourself. But if you want, you can always comment. What does obligate parasite? What does it mean? So afterwards, it inserts itself into a vertebrate host. So often in the liver. So into a vertebrate host. So vertebrate host, it can be what? It can be human. We have vertebrates. Okay, we have backbone, and usually in the liver. Okay. So liver, it doesn't get into the blood circulatory system right away. It actually goes into some other parts, specific parts. So often it goes into the liver, and then from the liver now it goes into the bloodstream, and then in the bloodstream it infects the red blood cells. Okay, this is how it basically does this. This plasmodium, which causes malaria, they're actually a handful, a bit different, but then they operate in the same way here. So just look up obligate parasite, and if you know what it means, just put it right there in the comment section. So let's quickly move to the next part. It says an element X has a nucleoid notation. This, okay. So what does P mean? So P is this part here. So when we have this one is called the mass number. That's one name, or you can also call it the nucleon number. Okay, nucleon number means protons plus neutrons. Neutrons, let me actually rub this and then just write it correctly. Protons plus neutrons, like this. And nucleon just simply means residence of the nucleus. So the residence of the nucleus, they are the protons and the neutrons. The electrons, they reside outside the nucleus. So they actually reside in electron shells. Okay, this one is called the atomic number. And why is this called the atomic number? Because this is the identifier. So in physical chemistry, this atomic number does not change. Okay, it only changes in nuclear chemistry. In physical chemistry, it may change in nuclear chemistry. In physical chemistry, this atomic number does not change. So if we just analyze something and then we check out the atomic number is the identifier for that atom or that element. So that's why we call it the atomic number. And this is also called the proton number. Okay. And the reason this is the proton number instead of the and not the electron number is that the proton number protons do not participate in the chemical reaction, so they make for good identifiers. If we were to use electrons, it'd be a big problem now, just because electrons, they participate in chemical reactions. So in ions, for example, the electrons there, the number of electrons in an ion, they are different than the actual atomic number. So you may be mistaken. If you check the number of electrons, then it's a problem. You're just supposed to check the proton number or the number of protons, and then you'll be able to find it. So here we said mass number. Nuclear chemistry, I think the questions that come in paper 1, ridiculously easy, okay? This is the stuff that you can do in 30 minutes and then just commit to memory. Mass number, again, means number of protons plus number of neutrons. They are the same mass in general. So one atomic mass unit, we say are 1 AMU. Each of them is 1 AMU. One is, there's an atomic mass unit that we use. It's equal to a 12th of, it's equal to 12th. The atomic mass unit is equal to a 12th of the mass of carbon 12. Okay, so the mass of carbon 12, the isotope of carbon, a 12th of that. If you're doing chemistry, then you're required to know this. If you're not doing chemistry, then just if you want to commit to memory, then that's okay. But essentially, this is how we measure the number of protons and the number of neutrons. So they're each 1, 1. Okay, so the proton number, neutron number, electron number. Yeah, so let's move to the next part. Next question, what does it say? Next question, it says the electronic configuration of a sodium atom is 281, and that of an oxygen atom is 26. What is the formula of the compound formed between sodium and oxygen? So the first thing that you have to know are the symbols for each. So for sodium, it's Na. For oxygen, it's O. Okay. So what I want you to do is you write the valence at the top of the number here. So the valence simply means the number of electrons that an atom is willing to lose or to gain so that it achieves its octet. So here the valence is 1. So we're going to take that valence as simply 1 just because it's less than 4. If it were greater than 4, for example, in the case of oxygen, then we would want the number of electrons required for that atom to achieve its octet state. So the octet state for the second shell here, it's 8. Okay, see here, sodium filled up its second shell with 8 electrons. This one also needs to do the same. So for that, it actually needs 2. Okay, so when you do like this now, what you just do is that this one goes there, this one goes there, and then you have your sodium. So you repurpose this as subscripts. Okay, so again, the valence for sodium, it's 1 because sodium only lose 1 electron. For the non-metal here, it's 2 because it wants 2 to complete its octet state. We write here it's 2, here it's 1. Then we interchange and repurpose them to become the subscripts. Okay, so it's actually B. Let's quickly move to the next part. So the next part says, let me just adjust my stuff real quick. Okay, we're back. So the next part says the diagram shows the type of bonding in a molecule. Okay, H represents an atom and X represents an electron. Okay, so this is the atom, and looks like it's a hydrogen atom. But then let's just go on. So what's the type of bonding shown in the diagram? So the type of bonding shown in this diagram, it's actually just covalent. Okay, why? Because there is a sharing of electrons. Okay, so in covalent there is always sharing of electrons. It means that no these two atoms, they won't be they are more or less the same. They have more or less the same power to attract electrons. It's called electronegativity. The electronegativity value, it's the same, and when it's the same, it means that no one electron can take all the electrons, so they are forced to actually share those electrons. So that's where we find. And then in ionic bonding now, we actually have complete transfer. That's when we have dot and cross diagrams where you see some atom there having, let's say, a dot from another atom or something like that. So there is complete transfer in the case of ionic bonds, but then there is no overlap here. It'd be different. for covalent bond, that's what we are seeing here. There's sharing of electrons. Let's quickly move to the next part. Which method is used to separate a mixture of dyes? So a mixture of dyes is used, we use the method of chromatography. If you didn't know this and um, you were widely read, then you probably got this hint here. Chroma usually use it to refer to color. So chroma has to do with colors, or dyes, it's also the same thing. And essentially what we do in chromatography is the different components of a mixture, they travel through a phase. So we have a stationary phase. You can put, let's say, a strip, and then you suspend that. So you're creating a phase where the dyes can climb up. But then when they do that now, climb up the paper, they'll be doing it at different rates, and thereby you're actually separating them. So they different dyes, they climb up or they travel through a phase at different rates, and thereby you're separating them. Okay, then year evaporation, it's not a method of separation. It's actually just something that happens. So evaporation simply means the change of state from what, from liquid to gas. Okay, then decanting, it's a method of separation, but it's just carefully pouring out the liquid part, and then you're left with something that sediments. So to decant, for example, you can decant water and sand. That solution you can decant. Okay, there you can decant. Then filtration. Filtration you probably know. If you don't know, look it up. And we're going to move to the next part. So which gas is produced when a metal reacts with an acid? This seems to be a popular question. I covered one paper 2, which is previously, I think it also had more or less it had sulfuric acid reacting with a metal, and then you asked what gas is produced. When a metal reacts with an acid, just know that hydrogen is produced. When an acid reacts with a carbonate, just know that carbon dioxide is produced. Okay, so carbonate plus an acid, that's when you have carbon dioxide. Then for oxygen and nitrogen, we're not going to cover that. Let's quickly move to the next part. And this one you use lime water, by the way. You probably know this, but lime water to test. Okay, so I think it gets creamy white. So from colorless to creamy white, I think you have to check this. But whenever you this is used to check if carbon dioxide is present. Okay, whenever you have a carbonate and acid reacting, if you want to check if carbon dioxide is present, use lime water. So the gas that's produced, you put it in lime water to test, and then if the lime water turns milky white, then you know that carbon dioxide is present. For oxygen, we use a glowing splint. Okay, chigamoto and in Shona. So a glowing splint would actually like relight if oxygen is present, because fire, it feeds off of oxygen to burn. Okay, let's quickly move to the last part. So the last question says, which substance A, B, C, or D have pH values shown in the, okay, substances have these pH values shown in this diagram. Okay, which substance is a strong acid? Okay, so this is the pH scale. pH scale is different than the OH scale. Okay, this is this measures the acidity, degree of acidity. So basically you could have values like 1.2 times 10 to the power negative, let's say 8 molar. This is molar concentration. Let's say it's for hydrogen. So it's freaking inconvenient. It's freaking inconvenient here, because you actually can't tell, is it really acidic, and to what degree is it acidic, compared to, let's say, something which is, let's say, 6 times 10 to the power, let's say, -4 this time. Would you be able to tell which one is more acidic, and to what extent? So if you want to get around this, you actually map these values onto the logarithmic, using a logarithmic function. And this function now, it gives you numbers essentially from 0 to 410, such that for pH, the lesser the number, the more acidic um, the the solution. Okay, so for our case, the most acidic solution would be A. So a pH scale, it's essentially a mapping of the hydrogen ion concentration. So we're actually measuring hydrogen ion concentration here. We put it like this in chemistry. Okay, that's what we are measuring, and we are putting it on a map such that we get corresponding values between 0 and 14. The lesser the number, the greater the acidity of that substance. So the strongest one would be the number with the least one, okay, least value. So it'd be A here. And then I also encourage you to just go and look at the pH scale, okay. Just look at what it is, a strong acid, what pH value would it have, and yeah, so you learn so much from that. So that's essentially the that's it for so our video, and then I'll catch you in the next video. Yuba out.